This is section 4.3, congruent triangles, and we're first going to look at some terms. Congruent, first of all, with geometric figures, this means that they have the same shape and size. So same shape and size. Congruent polygons, then, are polygons which have congruent sides and angles. And these have a special name for them. Those are corresponding sides and angles. So corresponding means that they match up. We have a definition of congruent polygons here. Two polygons are congruent if and only if their corresponding parts are congruent. So let's look at example 1 here, where we are identifying corresponding congruent parts. Let's say we have these two polygons, and remember, nothing I draw will probably be to scale, but we're going to get the idea here. And then we have another polygon. And this one is Q, R, T, P, and S. Pretty close. If we have to identify these corresponding parts, we could say that angle A is congruent to angle R. And we'd have angle B congruent to angle T. Angle B and angle T, then C and P. And it would continue with angles D and S and Q and E. So we would have 5 of them. I'm going to put dots there. We also then have congruent sides because they are corresponding sides. And we would have angle A, B, or I shouldn't say angle, it's segment AB, congruent to segment RT. And it's important that you list them in the same order here. Segment BC is congruent to segment TP. Segment CD congruent to segment PS. And then I think you can see that DE would be congruent to segment SQ and segment EA congruent to segment QR. So this goes on here with all 5 segments being congruent to each other, corresponding parts they are. And then lastly, we would have our whole polygon. Polygon ABCDE is therefore congruent to polygon RTPSQ. Now you complete Check Your Progress 1A on some paper. Okay, we are back for example 2, but before we start with that, I would like to point out once again that when you are talking about corresponding parts, you need to keep them in the same order. So let's up here put can't switch order. That is an important point to remember in all of this. Oops, sort of off the page there. Example 2, I've drawn in the figures already that we want to use. We are going to use our corresponding parts definition to come up with our missing values here for x and for y. So when we look at these triangles, you could rotate our second triangle here a little bit, this one. If we would rotate it to set upon this first triangle, we can use our figures or our values in our first triangle to help us calculate the values that are x and y in the second triangle. So we're going to start off by finding 6y minus 14. We're going to do that because this expression here only has one variable in it. So we start by setting 40, and I chose 40 because 40, that angle P, is corresponding to angle O here. So we set 40 equal to 6y minus 14, and we're going to add the 14 to each side. And we end up with 54 equals 6y. So when we solve for y, we divide each side by 6, and we have now found that y equals 9. We can then use that value when we go to find our missing x value. So in x minus 2y, when we look at this side in G, it corresponds to side IT. And since it does, we know that IT is 7.5 units long. So we can set those equal to each other, and we will then also substitute in our 9 for y. The 9 we found in our previous step. At this point, we have x minus 18 equals 7.5. Adding 18 to each side, we have x equal to 25.5. That is example 2. Now please complete check your progress number 2. Now for example 3. We first need to talk about theorem 4.3, the third angles theorem. And that states that if two angles of a triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So in your theorem there, you have missing the S behind angles, and then the words are congruent were cut off. So go ahead and add those. And now when we look at example 3 here, this one we are going to use that new third angles theorem. This is a picture of a tower roof. It's composed of congruent triangles that all converge at one point, and it's given to us that angle J is congruent to angle K. And I like to draw in the arcs then to show that those two angles are congruent, to help me remember that. It also says that angle J is equal to 72 degrees. So I'm going to write that in there so I remember that. But if J is 72 degrees, then K is 72 degrees. And now what we're asked to find here is the measure of angle JIH. JIH. We want to find this angle up here. Well, we know they are congruent triangles, and we have J and K both being equal to 72 degrees. So that means that angles H and J are also both equal to 72 degrees. And so would angles K and L over here. So since these angles are congruent, the J and this angle and the K, we know that these third angles, this one with the question mark and this one of this front triangle, are congruent. We can calculate out what this front triangle's angle is by taking 180, since all interior angles of a triangle add up to 180 degrees, and we'll subtract off the sum of those two angles, J and K. And when we do that, we find that we have a 36-degree angle here, and since this one is 36 degrees, our angle up here is also 36 degrees. Now you complete Check Your Progress number 3. The last thing we have to look at for this section are the properties of triangle congruence. We're going to skip proving two triangles are congruent at this time. But our properties of triangle congruence are the same as we saw earlier, back in, I think it was chapter 2, where we have reflexive, symmetric, and transitive. Now this also applies to congruent triangles, as you can see here. So for the first one, triangle ABC is congruent to triangle ABC. It's congruent to itself. So one way to help remember this is reflects. Close to the word reflection, you see yourself in the mirror. Same way here, it is congruent to itself. The next property is the symmetric one. So if triangle ABC is congruent to triangle DEF, then vice versa. Triangle DEF is congruent to triangle ABC. Now, symmetric, it talks about two halves being the same. So if you would fold these in half, you would get, if you fold them in half at the congruence sign, maybe I can do this here for you. Let me see. If I would fold this in half, right here, did you see when I folded them in half, triangle DEF was on top of itself and triangle ABC was on top of itself, and then when I open it up, I have my right order. Triangle ABC is congruent to triangle DEF, then triangle DEF is congruent to ABC. And lastly, we have the transitive theory, or property. So if triangle ABC is congruent to triangle DEF, and DEF is congruent to triangle GHI, then these two can overlap each other, and you're left with triangle ABC is congruent to triangle GHI.